Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ in front of you about allyl alcohol. So you can see the question and the options. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time you will get the right answer with proper explanation. But remember student, one statement: self-evaluation is essential for improvement, and that's why you should try. I believe you have tried by yourself, so it's my turn to give you the right answer. So you can see the problem now little carefully. So this part of this molecule is actually allyl alcohol, second part is SiMe3, and third part is actually aqueous HCl. We know this carbon silicon bond significantly stronger, and under this aqueous HCl condition it's less tendency to break. But there is another option. What do I mean? Because this HCl will produce this H plus and Cl minus, means acid. These H plus can protonate this allyl alcohol and reaction can start. So the first step of this reaction is the protonation of allyl alcohol into OH2 plus. Now we know that allyl alcohol can eliminate, means this OH2 plus in the allyl alcohol can eliminate efficiently because the produced carbocation is stabilized by the conjugation of this double bond. Okay, so in this case that's impossible, but since there is an adjacent SiMe3 group, so what can happen? This silicon could be attacked by water molecules oxygen lone pair. So after this attack, what it will do? This will come, it will come, and it will leave, and ultimately it will produce diene, or more specifically if I say 1,3-diene. And by the way, such kind of substrates are used in Diels-Alder reaction. I've already discussed. Now there are few questions appeared, because few questions are there. What do I mean? That why this water attacks this silicon? Because silicon is octet filled. Remember students, silicon has energetically accessible vacant d orbital. So that's why it can take the incoming nucleophile. So nucleophile can attack to the silicon center. Point number one. Second, there is another driving force for this reaction, that is formation of silicon oxygen bond, because in this reaction there is another product, trimethyl silyl alcohol, SiOH. Now this SiOH, if you look at this, has a significant stability. Why? Because it has one silicon oxygen bond, and we know that oxygen had its lone pair of 2 electrons in p orbital, and silicon has energetically accessible vacant d orbital. Okay, so it can overlap or delocalize the electron density on oxygen, and we know that delocalization means stabilization. So electron flow from oxygen side to silicon side happens. Now actually there was a sigma bond previously, so this is the sigma bond, carbon oxygen sigma bond, but along with this sigma bond there is some additional delocalization or back donation or bonding, like d pi p pi, d pi from the sulfur and p pi from the oxygen. So in this way, because of this back bonding, the bond order is more than single bond. So you can say that silicon oxygen single bond has some partial double bond character, more stronger bond, stable bond, and that's the driving force. And in this case there is one concept, but before going to that concept, you can see that what is simple Peterson olefination in acidic medium. So in acidic medium, what you can expect, that this OH2 will be protonated as OH2 plus, and there you can say that, so you can just forget this part, OH2 plus, and this is actually SiMe3. So what water molecule can do, water can act as nucleophile and attacks this silicon center, and what you can expect, that it will attack, it will come, and this OH2 is a good Leving group plus positive charge. Now in this way it will produce as alkene. So this reaction is called Peterson olefination. Now in this molecule there is an additional vinyl group, and that's why this is called vinylogous Peterson olefination or elimination, whatever you say. So this is actually a vinylogous system. Okay, and in case of Vinylogy system, the electronic property of the molecule is carry forward along with this carbon-carbon double bond. By the way, I have already discussed a dedicated lecture on principle of Vinylogy. You may visit for understanding this concept. It's a very important and interesting concept. So now previously there was already one double bond, and in case of this Petersen olefination, one double bond is produced here. So that's why ultimately it is actually an 1,3 diene. Okay, and these dienes are useful extremely in Diels-Alder reaction. I've already discussed. Now, so the key steps and the name reaction associated with this process is, the first one is protonation on hydroxyl, simply acid-base reaction, and we know that acid-base reactions are the fastest reaction. And in second step, Petersen olefination, or more specifically Vinylogy system. So in this way this product is produced. So what is the answer? Answer is obviously option B. Okay, and now question, if this question appears in your exam less than 30 seconds, how could you solve? First of all, you need to understand this is allyl alcohol. Second, aqueous HCl is given, so protonation will happen on the OH system. And third, that there is a SiMe3 in the allylic position too, so water molecule can attack and ultimately it may produce silicon oxygen bond, and in this case diene will be produced. So from these understanding few words, that first diene will be produced. So this option D and C gone. Now second, find diene. What type of diene? Now this OH will eliminate. So after this elimination, one double bond will be there at this OH and another carbon. So this one. Okay, and by the way student, that how this proton could be abstracted? It's not possible that much, because this is not a simple carbocation type, because of this presence of this silicon, it will participate, like it's a considered NGP type reaction. So that's why this is also not possible. So ultimately this is the answer. Now, so in conclusion, what you have learned today, that allyl alcohol could easily be dehydrated in presence of aqueous acid to produce corresponding alcohol. Sorry, alkene. In this case actually diene, because allyl alcohol. Now Vinylogy system could carry forward the electronic properties of the molecule through pi electronic environment. Now nucleophilic attack on the silicon center is possible due to the presence of energetically accessible vacant d orbital of silicon. Fine. And silicon oxygen bond is significantly stronger due to p pi d pi back bonding, and you can consider that this single bond is more than a single bond or partial double bond character it has, and these 1,3 dienes are utilized for Diels-Alder reaction. So this is the end of the discussion. I believe this video may be useful. Please write me in the comment box about your opinion, and if possible please visit my another channel where I upload global warming and climate change related